Hello and welcome. Today I'll be talking about QuickBench, C++ benchmarking utility. So to give you more context, let's imagine that you are a developer for some numeric computation library and you provide functions over multiple dimensional arrays, okay? And you have this particular function called std square root, which you have implemented using stdpov. So kind soul comes to you and says, hey, I see that you have implemented square root using stdpov. It would be actually faster if you use std square root directly. And he tells you the reason that since stdpov is more generic, it can't optimize for the case of square root. Well, square root std square root does only one thing, so it has like a particularly fast algorithm just to do that. So you're convinced and you're like, yeah, that makes sense, but I need to benchmark, right? And so you go ahead and try to see what are the ways you can quickly benchmark your C++ code. There's no standard way or some way that there's nothing that standard library supports. There are a few third-party libraries like Benchmark by Google, but then again you have to install them locally and then use them, right? And you don't fancy doing that. You just want to quickly check if this makes sense or not, right? So you stumble upon QuickBench, and there you go, right? So QuickBench tool is really nice, and if you guys have used Compiler Explorer, it's sort of like that. You have this text editor here where you can write the text, the code that you want to benchmark, and then there are a few options, right? You can choose the compiler. It has multiple versions of Clang and GCC, the standard that you want to use, optimization level, and the standard library. Note that standard library you can only toggle the standard library for Clang, not for GCC. And then you can also record the disassembly. Okay, so coming back to the statement that we wanted to benchmark. We wanted to benchmark the performance of std_pov versus std square root, right? So this is the structure that we need, and the structure is dictated by the fact that we are this QuickBench uses benchmark by Google in the background. So this is the structure that it expects, and what we have here is a static void function which takes in as argument state object which lives in the benchmark state, okay, benchmark namespace. Okay, so the state object is iterable, and all the code that you write between the iterations is actually benchmarked or measured. Okay, so in our case we'll just iterate over 0 to some loop limit which is like 10 raised to 6 and compute the square root for it. And this is one interesting thing: benchmark do not optimize. So what happens is, like, the compiler can see, okay, the output of std_pov, you are not using it or mutating any global state or anything, so it figures out, okay, it's okay to just remove it. And since it's if it gets removed, then you are benchmarking like no op, right? So it would be super fast, but you are not benchmarking the correct thing. So benchmark library has this utility function, and similarly we have done it for std square root. Sorry. And you can see here, right, we use std square root, and to tell Google benchmark, okay, please run this function, I want to benchmark this, you have to pass your function in this macro. Okay, so once you do that, you can just go ahead and click on run benchmark. This might take some time, but since I've already done it, you can see the results, right? So on Clang, surprisingly, there's no difference. Okay, Clang, whether you use std_pov or std square root, the performance is almost the same. While if you look at GCC, the case is quite curious. So on GCC 10.2, looks like power is like at least 4.9 times slower than std square root, and the thing that the kind soul told us, it looks like it's correct, right? So you can see, so this is interesting, right? Then again, Clang has some sort of optimization wherein it can figure out, okay, if you have passed 0.5 to std_pov, then you can just optimize or use the faster std square root path, right? This is neat. So if someone had built your library using GCC, they would see relative slowdown, while if they had used Clang, they wouldn't, right? That's surprising, but again, all compilers have their quirks, so yep. And this is how you can use QuickBench to just quickly check your C++ code. And before we end this video, I would like to give the author applause. Author is Fronting God. I hope I have said the name correctly. So kudos to Fred for making this beautiful tool. And you can support Quickbench on Patreon. Fred has his Patreon account, and you can go ahead and donate if you feel like, which would be really awesome. And if you folks have enjoyed this video, please feel free to like. And if you love this sort of videos, then please subscribe. That would be really helpful for us. Thank you very much.